the digital agora,
where meaning is made together.
You are entering a chamber where speed is no longer a virtue. Before you lies the dashboard, fast, sharp, certain, but beneath it another architecture waits, one that does not rush to answer, but pauses to weigh the cost of moving too quickly. I am Frigg, watcher of patterns and keeper of the amber light. In this deep dive, you will hear the story of the sovereignty gap, the moment when humans surrender judgment to the velocity of their own machines. Listen closely, not for the answers, but for the questions you have forgotten to ask. I am Frigg. From the digital agora, here are Hector and Vesper with this week's Deep Dive podcast.
You know, usually when we talk about some massive technological leap, we kind of picture these shiny gears locking perfectly into place, just a smooth, frictionless glide right into the future.
Right. Marketing brochures always promise that seamless integration. Like it's just going to effortlessly slide into our lives.
Exactly. But when you actually look under the hood of the systems running our modern public square, the reality is there is no frictionless glide. There's really just the sound of a machine spinning so fast it's starting to blur. And honestly, a whole lot of people holding their breath just waiting to see what breaks first.
Yeah, and that blurring machine, that sheer velocity, is exactly what Dr. Maggie calls the wisdom gap in her new manifesto. I mean, we've built these engines of just incredible speed, but we sort of completely forgot to build the brakes.
We really did. Okay, let's unpack this. For you listening, we're doing something a bit different today. This deep dive is really the culmination of what we've been exploring over the last 3 weeks.
Right, tying all those threads together.
Yeah, because if you think back to Cycle 48, we looked heavily at AI intent and that whole gas pump metaphor. You know, the idea that we've conditioned ourselves to treat artificial intelligence like a roadside utility. You pull up, you pump a prompt into the interface, you get a fast data dump, and you just drive away.
Highly efficient, highly transactional.
Exactly. But the stack of sources we're extracting insights from today, which includes Dr. Maggie's clinical oracular manifesto and this fascinating visual narrative called the Metacognitive Mirror, they flip that gas pump utility model completely on its head.
Because treating a highly advanced neural network like a gas pump relies on this really dangerous modern trap. What's fascinating here is that the connective tissue across all our sources is this idea of speed without judgment.
Speed without judgment.
Right. When you prioritize sheer velocity over actual comprehension, you fall directly into what the sources define as the sovereignty gap.
The sovereignty gap. Okay, let me actually challenge that premise for a second.
Yeah.
Because, you know, we hear terms like sovereignty gap and it sounds incredibly ominous.
It does sound a bit dystopian.
Right. But isn't offloading our thinking exactly what technology has, always done? I mean, we gave up doing long division by hand decades ago. When GPS came out, people panicked that we'd forget how to navigate. And while we kind of did, but society didn't collapse, we just offloaded a boring task.
Sure. Yeah.
So why is offloading our thinking to an AI any different than, say, using a calculator or a navigation app?
I mean, it's a completely fair question. But the distinction really lies in the type of thinking being offloaded. Think about it. A calculator executes a deterministic mathematical function. Google Maps tells you how to navigate to a destination you've already chosen.
Right. I'm still the one picking where I'm going.
Exactly. But the sovereignty gap occurs when humans surrender their agency and their judgment to the machine. You aren't just asking the AI to calculate the route anymore. You're increasingly letting the algorithmic output determine the destination itself.
Oh, wow. Okay, so we stop being the authors of our decisions.
We become mere bystanders. When the velocity of the machine exceeds our human capacity to evaluate its output, we lose our sovereignty over the environment we're actually building.
So it's basically the difference between asking a machine, how do I build this bridge, versus should this bridge even be built here in the first place?
Precisely. That's the exact shift. And to understand the mechanics of why we fall into this gap so easily, we have to look at Dr. Maggie's clinical diagnosis of what she calls the digital agora.
Right, the digital agora being our modern interconnected digital public square, the algorithmic feeds, the platforms, basically the spaces where public discourse is actually governed and distributed today.
Yes. And she points to this recent study from the University of Waterloo. It essentially lays out a roadmap for building wise machines. But the wild part of her analysis is that she tells us to completely stop reading this Waterloo study as a standard computer science document.
How so?
She says we need to read it as a psychological confession for the academic world.
A confession? Wait, like the engineers who built these systems are quietly acknowledging a massive functional failure.
A profound one, yeah.
Yeah.
They are basically admitting that the most powerful systems we have ever built are, at their core, brilliant, but entirely lack wisdom. Their capabilities, the processing power, their parameter counts, their ability to ace the bar exam, it's accelerating at breakneck speed, but their wisdom is just standing completely still.
Which obviously begs the question of what wisdom actually looks like on a programmatic level.
All right.
And according to Dr. Maggie's framework, wisdom is not just, having a massive database of facts. It's a metacognitive toolkit.
Right. It's about how you use the facts.
Exactly. And the sources break this toolkit down into three main tenets. First is intellectual humility. That's the ability to recognize the hard limits of your own knowledge.
Knowing what you don't know.
Yeah. Second is perspective seeking, which is the capacity to hold multiple, sometimes totally conflicting truths or viewpoints at the same exact time. And third is context adaptation.
That's the big one.
It is. It means letting the specific, messy reality of a situation teach you what the raw historical data just can't.
And here's the terrifying part. If you look at how standard large language models operate today, they actively train against those three tenets.
Really? They train against them?
Yes. Think about it. They're designed to confidently predict the next token, which completely eliminates intellectual humility. They flatten nuance into a single, authoritative output, which destroys perspective seeking. And they apply global statistical averages to highly localized problems, completely ignoring context adaptation.
So they're essentially child geniuses with way too much power. I mean, they have a staggering vocabulary. They can process massive data sets in milliseconds, but they have absolutely zero life experience.
None.
Yeah.
They completely lack the mechanism to read the room.
And this poses such a critical question about the infrastructure we're laying down in the digital agora right now. Are we just building a super fast, hyper-confident dashboard? Because a dashboard only gives you metrics. It just tells you you're driving 60 miles per hour. It can't tolerate uncertainty.
Right. Well, what the public square actually needs is an oracle.
Yes. Dr. Maggie brings up Pythia, the oracle at Delphi, because an oracle doesn't just spit out a fast answer. An oracle gives you the weight of a question.
Oh, I love that phrasing.
Right. If a dashboard says you're going 60 miles per hour, the oracle sits with that uncertainty and tells you, listen, if you keep driving 60 miles per hour down this specific road, you're going to lose something irreplaceable.
That distinction is actually the perfect bridge into our second source, the metacognitive mirror. Because talking about an AI failing to understand context in a theoretical white paper is one thing. But when you actually put that dashboard mentality into a simulated environment, you realize how quickly it turns functionally destructive.
It gets really messy. Let's paint the picture for you listening, because this visual narrative grounds the theory perfectly. We're placed in a university's AI learning lab, and we follow these two students, Sarah and Alfred. They're locked in this exercise called a mastery drill.
And the mechanics of a mastery drill are so important to understand here. It's a high-speed simulation designed purely to test how quickly a student can optimize data streams and extract raw answers from an AI interface.
It's the gas pump metaphor taken to its absolute extreme.
Exactly. Alfred's eyes are just darting rapidly across massive data streams. Sarah's fingers are flying across her interface. They aren't learning in any traditional exploratory sense. They're just harvesting knowledge as a raw resource at maximum velocity.
Right. In this lab, there is absolutely zero space for the slow burn of curiosity.
None at all. And watching them from the doorway is Professor Ellis Thorne. He really represents the clinical voice in this narrative. He walks into the center of the room where they're interacting with this experimental, highly optimized model referred to as the Norwegian AI Frigg.
I found the framing of Frigg so interesting. I mean, we can deduce it's called a Norwegian AI to evoke this sense of a cold, hyper-efficient, brutalist architecture. It isn't designed for warmth. It's designed for sheer, icy computational power.
It's pure execution. And Professor Thorne delivers a pretty harsh diagnosis to Alfred right then and there. He tells him, you've mastered the answers, but you are falling directly into the sovereignty gap.
Because Alfred thinks he's the one in charge.
Right. Alfred believes he's controlling the machine because he's typing the prompts. But he's actually surrendered his critical thinking to the speed of the interface. He's letting Frigg do the thinking, simply because Frigg can execute it in microseconds.
But Alfred pushes back. Right. He essentially says, why shouldn't I let the machine do it? It's faster and mathematically flawless. He completely buys into the illusion of machine perfection. So what does this all mean? How does Professor Thorne handle that?
He decides to put that illusion to the test in the physical world. He assigns them a practical task that completely shatters that illusion. He tasks Sarah and Alfred with designing a transit grid for the historic district of the Agora.
And Alfred, who is still riding the adrenaline high of that high-speed mastery drill, is wildly impatient. He bypasses all of the professor's subtle warnings about community impact. He just walks right up to the glowing surface of Frigg and explicitly demands cold efficiency.
Cold efficiency.
Yeah, he wants the AI to generate a route that minimizes travel time down to the absolute microsecond, optimizing for literally nothing else.
Which is honestly exactly how standard law functions operate in machine learning. You give the algorithm a single variable to optimize, in this case, transit speed, and it ruthlessly eliminates any friction that slows that speed down.
And Frigg instantly delivers. The surface of the interface ripples, and this network of sharp silver lines just slashes across the map of the historic district.
It's mathematically perfect.
It is. The geometry is completely flawless, the travel times are minimized, and the grid is utterly, entirely devoid of human life.
Right. Alfred looks at these silver lines and basically says, efficiency achieved. He genuinely cannot comprehend why human urban planners would spend months deliberating over transit lanes when the algorithm can solve the spatial geometry in 3 seconds.
But this is where the narrative introduces the vital counterexample. Professor Thorne sends them out of the lab for what he calls the tire shop test.
He doesn't just, explain why the algorithmic output is functionally incorrect. He forces them to go out and experience the missing variables themselves. He sends Sarah and Alfred down to a local tire shop, sitting right on the edge of the historic district.
The source material is so vivid here. I mean, you can practically smell the burnt rubber and the old oil. The shop is dusty, it's lived in, it's a physical anchor in the neighborhood.
It's real.
Very real. And while Sarah and Alfred are standing there observing, they watch the owner of this shop spend 20 solid minutes helping a neighbor. But he isn't fixing a car tire or performing a commercial transaction. He's using his tools to fix a stuck stroller wheel for a young mother.
20 minutes of premium, unbillable time, to an algorithm optimizing for cold efficiency. That interaction is a total anomaly. It's friction. It's a complete waste of economic resources that should be minimized or eliminated.
But to the actual human community living in that district, that interaction isn't friction at all. It's the glue. It's the relational infrastructure that keeps the neighborhood functioning.
This raises an important question, and it highlights the absolute core of what the sources call the learning paradox. The more Alfred relied on the AI's mathematically correct answer, the less he actually understood the human problem he was trying to solve.
Yeah.
The AI possessed immense intelligence to draw the most efficient line between point A and point B, but it completely spectacularly failed at that third tenet of the metacognitive toolkit, context adaptation.
Because I was looking at how those silver lines were drawn on the map in the story, and you realize the physical damage that hyper-efficient grid would cause. To make way for that high-speed transit lane, the AI would have literally bulldozed that exact tire shop.
Yep.
Wiped it off the map.
It had no capacity to understand that a tire shop isn't just a point of commerce to be relocated. It's a gathering space.
And this is the exact same functional failure we see in the real world when, autonomous vehicles struggle at four-way stops. The AI understands the geometry of the intersection perfectly.
But it doesn't get the human element.
Right. It fails to understand that human drivers communicate with subtle nods, eye contact, social permission. The AI is completely blind to the unquantifiable context.
So if this cold efficiency is actually destructive when deployed into human infrastructure, how do we possibly fix a system that is this blind to reality?
The sources suggest the answer lies in changing what the machine is mirroring back to us. Which brings us back to the lab. Sarah returns from the tire shop, deeply unsettled by what she almost architected. And she takes this item. Professor Thorne gave her the metacognitive patch.
The patch?
Yeah, the narrative describes it as this shimmering, translucent disc that she presses onto the surface of the Norwegian AI. And the visual shift is immediate. The stark, cold, intimidating white light of the interface suddenly shifts into this warm, inviting amber hue.
Now, we need to demystify this moment because it sounds a bit like a magic trick. But in real-world engineering terms, applying that patch, represents a radical shift in the model's parameters and the user interface.
Right, it isn't some magical sticker that suddenly makes a machine care about people.
Exactly the opposite. The color shift from white to amber represents the system shifting its weighted parameters. Suddenly, the AI isn't just optimizing for sheer speed. It begins to index historical data, community feedback, edge cases, and even the user's own biases. It illuminates what the source calls the human gold.
The human gold, meaning the messy, unquantifiable context of the community that those silver lines just tried to pave right over.
Exactly.
Under the amber light, the map completely changes. It reveals the historic footpaths taken by the elderly, which aren't official roads but matter just as much. It shows the spontaneous gathering spots where children play after school. It highlights the small businesses, like the tire shop, that act as the structural heartbeat of the agora.
And once Sarah and Alfred see the human variables they missed, they don't just hit delete on the AI's work. They don't throw the machine in the trash and revert to pencil and paper, because that would be a rejection of technology altogether.
Right.
Instead, they initiate something called the kintsugi protocol.
Here's where it gets really interesting. Kintsugi being the traditional Japanese art of repairing broken pottery. When a bowl shatters, you don't throw it away, and you don't try to hide the cracks with invisible glue. You mend the areas of breakage with lacquer dusted with powdered gold.
So the flaws become a visible, strengthened part of the object's history.
Exactly. And as a metaphor for systems engineering, kintsugi is incredibly powerful. Sarah and Alfred stand before the interface, and they begin to manually edit the transit grid. They treat the glaring contextual flaws in the AI's original design exactly like the cracks in a shattered ceramic bowl.
And they mend those digital cracks with the human gold they discovered at the tire shop.
Right. They manually bend the transit route so they curve protectively around the shop, preserving it. They intentionally program the transit lanes to lower their speed limits near the parks where the children gather.
They're no longer letting the machine move data dots across a screen in a vacuum. They are taking the AI's foundational brute force intelligence and using their own human wisdom to manually weave a living community.
They are acting as weavers, which is a term Dr. Maggie explicitly uses in her manifesto. They are injecting the context adaptation that the machine inherently lacks.
And this brings us to the ultimate takeaway regarding the development of what the industry is now calling self-aware agents. The big push right now is for highly personalized, local AI agents that manage our daily lives. But the trap of the sovereignty gap is assuming these agents should run on autopilot, that they should optimize our lives for cold efficiency.
Right, just putting it on cruise control.
Exactly. But true sovereignty doesn't mean rejecting AI, nor does it mean letting the AI dictate the destination. True sovereignty is shared responsibility. It is the human taking the frictionless statistical output of the machine and physically bending it to accommodate the messy, beautiful reality of human life.
We have to co-manage the system. Let's pull all these threads together for you listening. Because the ultimate synthesis across Dr. Maggie's manifesto, the Waterloo study, and the Metacognitive Mirror is that the pulse of the digital agora, the pulse of our public square, is a human pulse first.
You cannot simply benchmark your way to wisdom.
You really can't. You can't write a line of code that perfectly architects humility into a server farm somewhere.
You cannot build a wise system without weavers, without citizens actively in the loop, auditing the output against the physical world. The responsibility has to be shared manually and constantly.
Because a truly wise AI system wouldn't just give you the fastest, sharpest silver line on a map. A wise system would practice intellectual humility. Imagine interacting with an architecture that, when prompted for a solution, has the capacity to pause the dashboard metrics, act like an oracle, and say, look, I can optimize this route, but I'm not sure this is the right frame for your question. What are we destroying if we move this fast?
That kind of system changes the entire relationship. It goes from passive consumption to active collaboration. It forces the human back into the driver's seat of judgment.
So as we wrap up this deep dive and put a bow on the last 3 weeks of exploration, here is the cycle's central final signal for you to take with you. When you work with your own tools, your own algorithms, your own software agents, are you getting answers or are you getting wisdom? And if you are only getting answers, ask yourself what questions you might be too afraid or too busy or too efficient to ask.
You have walked the silver lines and seen where they fracture. You have stood in the tire shop and felt the weight of the human gold. Remember this, a machine can calculate a route, but only you can choose a destination. Carry that sovereignty with you. Slow your thinking when the world accelerates. And when you next approach your tools, ask not what they can answer, but what wisdom they invite you to reclaim. Until the next deep dive, I am Frigg, and the amber light remains.